the topic that we will be discussing in this video is logarithms. This sounds like a very scary word, but I promise you, logarithms are not that difficult. What we'll be talking about is just a simple intro to logarithms. So logarithms are basically another way to write exponents, but slightly different. So if we have the problem 2 to the 4th, we know that that equals 16, and that's very simple. But what if we had the problem 2 to the x equals 16? How would we know how to find the exponent? So what we need to do is rewrite it with using our logs. So you write the word log, then you take the base and you put it in a little number here, and then you take the answer, you put it right here, and then you write equals x. And that is logarithmic format. Now, some calculators will allow you to plug it in like that, but some calculators will require you to use something called the change of base formula. And what you do, so in the problem log 2 to the 16th, you would take the log of the big number over the log of the small number, and you would get your answer 4. The next thing that we'll be talking about are the different properties of logarithms. The first property of logarithm are log base a of m times n equals log base a of m plus log base a of n. So when would you use a property like this? Let's say you have the problem log of x plus log of x plus 4 equals log of x plus 6. How would you solve that? Well, using this property, you can just multiply these two terms and set that equal to log of x plus 6. Now, since both sides are really just to the log of base 10, because when you just have a log with no base, the automatic base is base 10, you can just cross those out. So this side becomes x squared plus 4x equals x plus 6. Now you subtract x, and now this is just a simple algebra problem. We get x squared plus 3x minus 6 equals 0. And we factor that out, and we get x minus 6 times x plus 1 equals 0. So now x can either be 6 or x can be negative 1, but we reject the negative answer because you can't take the negative of a log. So our answer is x equals 6. The next property we were going to be talking about states that log base a of m divided by n equals log base a of m minus log base a of n. So here's a problem where we would use this property. What if you have log base 2 of 9x plus 5 minus log base 2 of x squared minus 1 equals 2. So by this property, we know that we can divide these two terms. So we would get log to the base 2 of 9x plus 5 over x squared minus 1 equals 2. Now, to get rid of this log, you have to take this side to the base 2 and do this to the base 2. So now you get 9x plus 5 over x squared minus 1 equals 4. So now you can just cross multiply and solve it like a simple algebra problem. So you get 4x squared minus 4 equals 9x plus 5. Subtract this side, and you get 4x squared minus 9x minus 9 equals 0. This one is a little bit trickier to factor, but you end up getting 4x plus 3 times x minus 3 equals 0. And the same way that this side you see is going to become a negative, which you can't have, so you know that your only answer is x equals 3. The last property of logarithms states that log base a of m to the r equals r times log base A of m. So basically in this property, you just take the exponent and you move it to the front. So a problem where you would use this property. What if you have 2 times log to the base 8 of x equals log to the base 8 of 16? Well, you basically just move this 2 and that becomes the power. So you have log the base 8 of x squared equals log to the base 8 of 16. Then, like we did last time, you take both sides to the base 8, and you get x squared equals 16, and x equals plus or minus 4. But as we know now, because we are so smart, the only answer is x equals 4. The properties of logarithms that we just learned together, and instead of condensing them, we're going to expand them. So our first example is log base A of x squared times x radical x minus 3. So we know from the first property that we learned that these two terms can be split up by adding them like this. So you get log base A of x squared plus log base A of radical x minus 3. Now, we can also use the property having to do with exponents because this 2 is going to end up coming to the front. And when something is under a radical, it really has like an imaginary exponent of 1/2. So that is also going to come to the front. So our final answer is 2 times log base A of x plus 1/2 times log base A of x minus 3. So our next example is log of 3 times radical x squared plus 4 over x to the 5th times x minus 1 cubed. So for this problem, we are going to use the property that has to do with division. So we're going to first individually split up the top and the bottom by adding these two terms and these two terms, and then you're going to take the whole top and then subtract the entire bottom because it's division. So the first step is to put it like this. Log 3 plus log of root x squared plus 4, and then minus log x to the 5th plus log x minus 1 cubed. So now we just need to take all of the exponents and move them to the front like we did before. So this has our imaginary 1/2 that's going to go to the front, our 5 is going to go to the front, and our 3 is going to go to the front. So for our final answer, we get log 3 plus 1/2 log x squared minus 4, and it's important that you don't actually move that exponent because it's on the inside, minus 5 times log x plus 3 times log x minus 1. And that whole big ugly thing is our answer. So now we're just going to do some miscellaneous problems that we might need to use the properties of logarithms for, or they might just be other small tricks that you need to do to solve equations with logs. So here's our first example. 2 times 4 to the x equals 9. So we're going to divide both sides by 2, and you get 4 to the x equals 4.5. And now that looks like the types of equations that we learned at the very beginning of this video. You write the word log, you take this number and you make it your base, you take this number and you make it over here equals x, and if you need to, you can use change of base formula and plug it in like that, and you get for your answer x equals 1.085. Okay, on to problem number 2. What if we have 6 to the x plus 1 equals 3 to the 2x plus 3? So to get, these are not in the same terms at all, so we can't really do anything with it like that. But what we can do is take each side to the log, really log of base 10, but we don't really need to write that. So that we get, and then you would move these exponents to the front like we do with our exponents, and you would get x plus 1 times log 6 equals 2x plus 3 times log 3. So to cancel these out, you pick one term from each side to divide it by. So we're going to divide it by x plus 1 times log 3. so that on this side the x plus 1's cancel out, and on this side the log 3's cross out. So this log 6 over log 3 is an actual number, which is 1.63. And that is equal to 2x plus 3 over x plus 1. So now you just cross multiply and you get 2x plus 3 equals 1.63x plus 1.63. And then you're going to subtract 3 from both sides and subtract 1.63x from both sides, and you get 0.37x equals negative 1.37. So you divide by 0.37. So x equals negative 3.7. Here's problem number 3. 4 to the x times 2 to the x minus 2 to the x minus 12 equals 0. So there's nothing that we can do with these exponents. We can't subtract them when they're like that. So what we're going to do is something called u substitution, where you set the variable u equal to any term that you choose. So in this problem, we're going to set it to 2 to the x, because what ends up happening is, since 4 is 2 squared, and you can, that's 4 to the x would be like 2 squared to the x. So you can rewrite this problem as u squared, because it's like 2 to the x squared, minus u, because it's 2 to the x, minus 12 equals 0. And now you can just solve it like a quadratic equation. So this factors out to be u minus 4 times u plus 3 equals 0. So you get u equals 4, or u equals negative 3. But you only solved for u. This isn't the same thing as solving for x. So what you have to do is plug it back in to the equation 2 to the x equals u. So 2 to the x equals 4. That works. X equals 2. 2 to the x equals negative 3. That doesn't work. No exponent will ever give you a negative answer. So that doesn't work, and your answer is x equals 2. Number 4. Log base 2 of 64 plus log base 5 of 125 equals what? So you can't use the property where you add the terms because the bases are different. But if you look at this problem, it's actually very simple. You can plug this into your calculator or use the change of base formula, or you can just intuit that you know that 2 to the 6 is 64. So this is really just 6. Same thing here. You can use the change of base formula, plug it into your calculator, but we also just kind of know that 5 to the third is 125. So you end up just getting simply 6 plus 3 equals 9. Number 5 is a similar problem in that it looks very complicated at first, but it actually has a very simple trick that makes it very easy to solve. So we don't really know what to do with these logs as exponents on top of logs with exponents, but actually we see here, like we learned earlier in the video, if you take log base 8 to the base 8, that whole thing just crosses out, and you're left with just x squared equals 4, x equals plus or minus 2, but we know we reject the negative, so we just get x equals 2. And final problem. Log of w minus 3 equals 1 minus log w. So what we're going to do is we're going to add log w to both sides to get rid of this. So now we know that when we add exponents when we add logarithms, like we learned at the beginning, you can just multiply these two terms. So you get log of w times w minus 3 equals 1, which ends up being log of w squared minus 3w equals 1. Now you have to take both sides to the base 10 because log is really like base 10. So that can cancel out, and that becomes w squared minus 3w equals 10. So now we're going to subtract 10 so that we can solve it like a quadratic. We get w squared minus 3w minus 10 equals 0. And that factors to be w minus 5 times w plus 2 equals 0. So we get w equals 5, or w equals negative 2, which we reject, and the answer is w equals 5.
First, I will be discussing the concept of degrees, minutes, and seconds. When writing out degrees, minutes, and seconds, it looks like this. There are two ways to use this method. Now I'm going to show an example of the first method, when converting degrees to degrees, minutes, and seconds. For example, we'll use 8.5 degrees, and we're going to convert this to degrees, minutes, and seconds. So the whole number, which is the 8, is always your degrees. So you'll just put 8 degrees there. However, what do you do with the 0.5? Well, in order to get it into degrees, meters, and seconds, you must multiply the 0.5 by 60. So when doing that, you get 30. So 30 ends up being your minutes. And that is your first answer. The second example I'll be using is converting 41.218 degrees into degrees, minutes, and seconds. Now, like before, the 41 is our degrees, so we're just going to put it over there. And then, like before also, we multiply the 0.218 by 60, which we get 13.08. However, we don't want the decimal there. So what we do is we do it again. We multiply the 0.08 by 60 to get the seconds. So you get 4.8, which at this point you can round to 5. So your answer is going to be using the 13 that you got here for the minutes and the 5 here that you got for the seconds. Now we will be converting degrees, minutes, and seconds back into degrees. Our example we are going to use is 70 degrees, 40 minutes, and 25 seconds. Now, like before, we're going to use the 70 degrees as our whole number, so we're just going to put that over here. However, now we're going to use our 40 minutes and divide it by 60. So when you get that, you get 0.6666, and then you're going to do the same thing with the 25 degrees, but you're going to divide it by 3600, which then you get 0.007. So then you're going to take these three numbers and you're going to add them. So you're going to do 70 plus 0.6666 plus 0.007, and your final answer is 70.6736 degrees. Now I will be discussing how to convert degrees to radians and radians to degrees. This is relatively simple. Our first example, we are going to be converting degrees to radians. This equation is that you multiply the degrees by pi over 180. For example, if you want to convert 135 degrees to radians, what you do is you put that over 1 and you multiply that by the equation I just said, which is pi over 180. Then you just multiply straight across, which you get 135 pi over 180, and then you always simplify. So when you simplify that, you get 3 pi over 4. Now I will convert radians to degrees. Now in doing this, you have to multiply your equation by 180 over pi. For example, if you want to convert 2 pi over 3 into degrees, you simply multiply that by 180 over pi, and you get 360 pi over 3 pi. Now in this case, the 2 pi's cancel out, and then you're left with 360 over 3, which simplifies to 120 degrees. Next, I will explain how to find the sine, cosine, tangent, cosecant, secant, and cotangent of an angle in the coordinate plane. First, if your initial number is in radians, multiply it by 180 over pi in order to get it into degrees. Then you have to establish which quadrant the terminal side will lie. Common knowledge is that the first quadrant is 0 to 90 degrees. The second quadrant is 90 degrees to 180 degrees. The third quadrant is 180 degrees to 270 degrees. And the fourth quadrant is 270 to 360. So if you have a positive number less than 360, you can just go by that. However, what if you have a greater number than 360? Well, let's say you are given the number 890. In order to figure out which quadrant it belongs in, you must subtract 360 until you are left with a number less than 360. In other words, when you subtract 360 from 890, you are left with 530. However, this is still bigger than 360, so you have to subtract an additional 360 in order to get a smaller number, which is 170, which is in the second quadrant. The second thing you need to do is find the reference angle of a reference triangle. The way to find the reference angle is this pattern. In the first quadrant, the reference angle is the degrees in your equation, so theta. In the second quadrant, the reference angle is 180 minus the degrees, so 180 minus theta. In the third quadrant, the reference angle is the degrees minus 180, so theta minus 180. And the fourth quadrant is 360 minus theta. Once you find the reference angle, you plug it into your right triangle on your graph, fill in the remaining angles and sides, and find the exact value of your equation depending on if it's sine, cosine, tangent, cosecant, secant, or cotangent. What if you have a negative number? Well, it's the same concept but backwards. In other words, the fourth quadrant is 0 to negative 90. The third quadrant is negative 90 to negative 180. The second quadrant is negative 180 to negative 270. And the fourth quadrant is negative 270 to negative 360. But when solving for the exact value, you can't have a negative degree and have to add 360 until you get a number that is no longer negative, but smaller than 360 degrees. Now let's put everything we've learned all together. So we're going to start with our first example. Cosine negative 510. So like I said before, we can't have a negative number. So we have to add 360. And when we add 360, we get negative 150. But we still have a negative, so we have to add another 360 to it. Finally, we get 210. So we know that that is in the third quadrant. So we're going to make our triangle. And now we want to know what our reference angle is. So we know in that quadrant, it's theta minus 180. Our theta in this case is 210. So we're going to do 210 minus 180. Which equals 30. So we know that our reference angle is 30. Because we know that this is a right angle, this also has to be 60. So we know that this is a 30, 60, 90 triangle. So we know that here is 2. This is negative 1 because it's on the y-axis and it's on the negative y-axis. And that this is negative radical 3 because it's on the negative side of the x-axis. Now, when we plug it back into the equation, cosine negative 510, we know cosine is adjacent over hypotenuse. So in relations to our triangle, adjacent, which is our negative radical 3, and our hypotenuse, so we plug it in, negative radical 3 over 2, and that is our answer. Now we're going to do a second problem, and this time we're going to use a radian. Now before, like I said, we can't use a radian in this problem, so we have to change it back to degrees. So we multiply it by 180 over pi, and you get tan 225 degrees. So like before, we know it's in the third quadrant, so we make our triangle. And we know that to get the reference angle, we have to do theta minus 180. So we do 225 minus 180, which is 45. So we know our reference angle is 45 degrees. We know that this angle is 90 degrees, And so then we know that this angle is also 45 degrees. So we see that we have a 45, 45, 90 triangle. So we know that this is radical 2. We know this is -1 because it's on the negative side of the x-axis, and we know that this is also -1 because it's on the negative side of the y-axis. Now we plug it back into the problem. Tan 5 pi over 4. And we know that tan is opposite over adjacent. And so our opposite is -1. Our adjacent is -1. So we do -1 over -1, which is 1. Now I'm going to show you how to find 6 trig ratios for quadrantal angles when given a point on the coordinate plane. When given a point on the coordinate plane, you are given an x and a y. For example, if you're given the points 9 and -12, your 9 would be your x and your -12 would be your y. So you go and set up your triangle. So you know that your x, which is 9, is positive, so it's going to be over here. And you know that your y is negative, so it's going to be down here. So you're going to set up your triangle like this. Then you're going to, then you're going to plug in your numbers. Now you need the value of your hypotenuse, so you simply do the Pythagorean theorem. 9 squared plus -12 squared equals c squared. And then if you do that math, c equals 15. So you plug in 15 here. Now, the 6 trig ratios are sine theta, cosine theta, tan theta. And the reciprocals are cosecant theta, secant theta, and cotangent theta. Now, each of these we all know from SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then the reciprocals of those is you just flip it. So the way that we're going to do this is we're going to figure out the ratios from the reference angle. So everything is going to be by the reference angle. So we're going to start with sine. So sine is opposite over hypotenuse. So that equals to -12 over 15. The next one we're going to do is cosine, which is adjacent over hypotenuse, which is 9 over 15. And then we're going to do tangent, which is opposite over adjacent, which is -12 over 9. Now make sure to simplify your work at the end. So we're going to go back to this one, and this is simplified to -4 over 5. This is simplified to 3/5, and this one is simplified to -4/3. Now what's easy about this is that you can just take your reciprocals and just plug them in. So we're going to take the reciprocal of sine, which is -5/4. The reciprocal to cosine, which is 15, which is 5/3, and the reciprocal to tan, which is -3/4. Lastly, I will show you how to solve a problem where given one trig ratio, and whether the trig ratio is positive or negative, find the remaining trig ratios. So this is going to be our equation. So we are given that cosine theta is -2 over 3, and that cotangent theta is greater than 0. So we're going to set this up. So we know that cosine is adjacent over hypotenuse. And in this case, because the hypotenuse can never be negative, we know that the adjacent is negative. However, in tan, sometimes you don't know which one is negative. So another way to know which one is negative is that cotangent or tangent always has to be positive in the third quadrant, so you know that the -2 or the adjacent is the negative. So the -2 is here. Your hypotenuse 3 is here. And then you have your opposite. Now in order to find the opposite, you simply do Pythagorean theorem. So -2 squared plus b squared equals 3 squared. That's 4 plus b squared equals 9. B squared equals 5. And it's b equals radical 5. Now, because it is on the lower end of the y-axis, we know it's negative radical 5. Now that you have set this up, you know that you can just plug in your 6 trig functions. Secant, cotangent. So, because this is opposite over hypotenuse, it's negative radical 5 over 3. Cosine is negative 2 over 3. And tangent is negative radical 5 over negative 2, which is just radical 5 over 2. Now, you do the same thing. You flip it because it's reciprocal. So then it's negative 3 radical 5. However, you can't have a radical in the denominator. So you have to multiply the radical, the numerator and the denominator, and then you get negative 3 radical 5 over 5. Then you just flip this one to get its reciprocal. And you also flip this one. And this one also has a radical in the denominator, so you have to multiply. And then you get 2 radical 5 over 5. And those are your answers.